So what I'd like to do is kind of give you a preview for some of the more powerful techniques that I guarantee will really help raise your score down the road. So to get started, I'm going to have you try the question in the workbook that starts off with if X oranges cost C cents. And give that one a try to come up with an answer, and then come on back. Hopefully you had a hard time with that question. I found in teaching that if you give a kid a question that he gets wrong, he tends to listen to you a lot closer when you explain how to do it. Interesting thing with the SAT, it's been around for about 110 years. And for about the first 80 years or 90 years of its existence, the test makers didn't let kids bring calculators into the test. About 15 years ago, oddly enough, there is a council of mathematics teachers, which was all up in arms about this. And they were saying, look, these guys are using calculators in school all the time. Why can't they use a calculator on the SAT? So anyway, what happened is that the Educational Testing Service broke down and said, fine, we're going to allow you guys to bring calculators into the test, but we're going to make sure that there's not a single question on the test that requires a calculator. Okay, and you probably found with this question, you got variables, and you have variables in the answer. There's not really a whole bunch of an opportunity to use a calculator. Now here's the deal. What we're going to do is we're going to take advantage of the fact that we have a multiple choice test. All right? People are not wired to think algebraically. If I were to say to you, how far from the nearest hospital do you live? You're not going to say I live X minus 7 miles divided by 3, where X equals 12. You're going to say I live 5 minutes away, I live 10 minutes away, 4 miles. We think with numbers. This technique is called plugging in. And what we're doing is that we are taking an algebra question and we're swapping out good old-fashioned numbers, integers, for the variables. So in effect, we're turning an algebra question into an arithmetic question and solving it that way. Okay, so we have 4 steps to this technique. First of all, we're going to call the technique plugging in, because that's what we're doing. We're plugging in our own numbers for the variables and solving it that way. So step 1 is to choose numbers for all the variables. Step 2 is to solve the question using those numbers. Step 3 is an easy one. All you have to do is circle your answer. And the last thing you're going to do, step 4, is you're going to go through the answer choices, and wherever you see a variable, you're going to stick the number that you plugged in for that variable, and you're going to try to find the answer choice that you came up with. So let's walk through this question. Okay, so if X oranges cost C cents, we have to plug in variable or numbers for the variables that we have. So let's say 3 oranges cost 6 cents. If we do that, what we find is that each orange is 2 cents apiece. Okay, that's step 1. Step 2 is to solve the problem. And in this case, they are asking, how many cents will 5 oranges cost? Well, if oranges are 2 cents apiece, 5 oranges will cost you 10 cents. Our third step, I said, is going to be to circle your answer. So let's circle our answer, which was 10. This is our target, because when we go through our answer choices, what we're going to do is we're going to try to find the answer choice which gives us 10 when we plug in 3 for X and 6 for C. Let's take a look at answer choice A. We have 5 times 3, which is 15, divided by 6, which does not equal 10. Answer choice B would be 5 times 6 divided by 3, which would be 30 divided by 3, which equals 10. And 10 is exactly what we were looking for, so answer choice B is correct. The thing that you should realize about that question that we just did with the oranges is that on an SAT, that question would fall somewhere after question number 17. So that could be number 18, number 19, number 20. It's a really difficult question. Hopefully what you saw is that by using your own numbers and solving it in kind of an atypical, unorthodox way, you can make some of the more difficult questions actually really doable and quite easy. Let's take a look at the question that deals with Alice and her brother. And I'm going to walk you through this just to kind of give you another idea of how you want to work through these questions. The question says Alice is X years old and she's 3 times as old as her brother David. So in terms of X, how old was David 2 years ago? Okay, first of all, with the in terms of x, what you want to realize is that we're not doing this question algebraically, so we can cross that out. Okay, that's not going to come into play when we solve this question. So I'm going to cross that one out. But let's walk through the steps. The first thing we have to do is come up with a number for our variable, which is x. Okay, we know Alice is x years old, but we also know she's 3 times as old as her brother. So when we choose a number for Alice, you don't want to choose a number like 10 or 16 or something that's not divisible by 3. Okay, you want to make your life easy. So let's say that Alice is 12 years old. If Alice is 12 years old, she's still 3 times as old as her brother David. So how old would David be? Well, 12 divided by 3 would be 4, so David is 4 years old. That's step 1. We've chosen numbers for the variables. Step 2 is to solve the question. And this question is asking, how old was David 2 years ago? Okay, so David is 4 years old right now, so 2 years ago, he was 2. Now 2 is our answer. It's our target. So what we're going to do is we're going to circle 2 because that's what we're going to look for in the answer choices. Step 3, we just did. Circle your answer. It's an easy one. Now the last step is to go through the answer choices, and wherever we see an x, we're going to stick in whatever number we chose for x. And in this question, we chose 12. And we're looking for the answer which gives us what we circled, which was 2. So let's go through. Okay, answer choice A is going to be 12 divided by 3, which is 4. And 4 minus 2, sure enough, it gives you 2. And that's the correct answer. What you're going to find in this class is that we're teaching you a different way of approaching the SAT. If you took the SAT over and over again for however long, what's going to happen is that your scores might go up a little bit, they might go down a little bit, but basically you're going to stay in a range which is pretty narrow. So what you have to do is you have to approach the SAT a different way to actually raise your scores significantly. Okay, so there's a learning curve. Like I said, if you kept on taking the test over and over again, you're not going to vary too much. But what's going to happen is when we introduce a technique like this one, okay, this is where you are normally, you're going to drop down here at first because it's something new and something that you're not that comfortable with. But stick with it, because what you're going to find is that eventually you come back up to where you were. And the important thing is once you feel comfortable with the technique, that's where you can truly raise your scores. So it's kind of tough, but stick with it. Okay, now let's go through one more time. First off, choose numbers for all the variables. Second, solve the question. Third, circle your answer. And fourth, go through the answer choices and pick the one that matches what you circled. I'm going to have you try the Jimmy question now, and then we'll go over it. Okay, so with this question with Jimmy and his buddies, we know that he's got $5 more than Bill has, but he's got $3 less than Chris. Okay, so first off, we have to come up with a number for the amount of money Jimmy has. Let's say he has $10. Nice, easy, straightforward number. So if Jimmy has $10, how many dollars would Bill have? Well, Jimmy has $5 more than Bill, so Bill has $5. But Jimmy has $3 less than Chris. Okay, so if Jimmy has 10, he has $3 less than Chris, so Chris has 13. So that's step 1. We've chosen numbers for all the variables. We're done with that. Second step is to solve the problem. This question is asking how many dollars do Chris and Bill have together? Okay? Well, Bill has 5 and Chris has 13. So together, they have $18. 18 is our answer, so we're going to circle 18. The final thing we're going to do is go through the answer choices, and wherever we see X, we're going to stick in 10, and whichever answer choice gives us 18 is going to be the correct answer. Answer choice A would be 2 times 10, which is 20, minus 8, which does not equal 18. This one, 2 times 10 is again 20, minus 5, which is 15. So that's wrong. Answer choice C is 20 minus 2. Hot damn. 20 minus 2 is 18. C is the correct answer. Now you may be thinking to yourself, yeah, I didn't use 10, I used 6, or I used 11, or something like that. The cool thing about plugging in is that it doesn't matter what numbers you choose, okay? Because what happens is that algebra and arithmetic behave the same way. The only difference is that algebra has variables and arithmetic has numbers. So no matter what numbers you choose, you should be okay. And another thing that you may wonder is, when we come to an answer and it works, does it have to be the correct answer? The answer is 99.9% of the time, yes. As long as you chose good numbers to begin with, whichever answer choice fits will be correct. So we didn't use 0, we didn't use 1, we didn't repeat numbers, so we should be okay.